In this class, we'll cover the remaining part of factors affecting the upthrust. Basically, what we did last time was the pressure on the top is 10 Pascal, pressure on the bottom is 40 Pascal, and pressure on the sides is just for example 20 Pascal each. Then if you take this rigid object towards depth in liquid, if we are taking it towards depth in liquid, then all the sides will be move equal depth, and as a result the increase of pressure on all the sides would be same, and what we'll get is that if the pressure on the top is increased by 30 Pascal, just for example it becomes 40 Pascal after an increase of 30. Now this is P and this is delta P. This is increase. So if increase in pressure on the top is 30 Pascal, then on all the sides the increase would be 30 Pascal. This would become 50 Pascal. This would become this would become 50 Pascal, and from the bottom it would be 40 plus 30, 70 Pascal. Now you see pressure, the increase in pressure on all the sides is same. So we can say that the conclusion here is, since upthrust depends, excuse me, since upthrust depends on the pressure difference, it depends on the pressure difference and not the pressure difference between the top and the bottom. So the upthrust will remain same, as you see the increase in pressure on the top and on the bottom both is 30 Pascal. It remains same as the increase of pressure on the top and the bottom is same. Hence, the difference will remain Hence the difference will remain unchanged. And upthrust is not dependent on the pressure but on the pressure difference, which is unchanged. That's why the upthrust will not be affected. Upthrust will not be affected by increasing. Upthrust is not affected by increasing the depth of a fully immersed object. So if you increase the depth of a fully immersed object, it will not affect the upthrust at all. However, the pressure will go on. However, the pressure will go on to increase as you increase the depth, as pressure is a scalar and it will not cancel out. So the pressure will go on to increase as you increase the depth. So you will feel more compressed when you are at more depth inside the liquid. So with the increase of depth, the squeezing of effect or the compression will increase. That is because of the pressure. Pressure is the compressing force. While moving downwards in the water at depth, the compressing effect or the pressure goes on to increase, and you misjudge that for upthrust. Upthrust is the net or the resultant force that depends on the change of pressure, and since change of pressure remains same, so the upthrust is not affected with the increase of depth. However, the pressure itself, which is the compressing effect, will go on to increase when you move towards the depth. So these are the two things you have to understand. Now, one last thing is that if we immerse an object in the liquid, immersing an object in the liquid. For example, if we drop something into the liquid, then it will take some time to reach the surface of the liquid, then it will be immersed inside the liquid, and then when it is fully immersed, after that the depth will increase. If we plot a graph of upthrust against time, and this is upthrust due to the liquid and not due to the fluid, so upthrust due to the liquid for understanding. As long the object is not in contact with the liquid, it will not experience any upthrust. So up to a certain point, say T1, the object will not feel or experience any upthrust as it takes T1 to reach the liquid. So T1 is the time taken to reach or touch the liquid. So the object comes in contact with a liquid at time t1 seconds. Then as the object is immersed, the upthrust will go on to increase. Yet notice one thing, the speed of the object is decreasing. That's why the rate of increase of upthrust is decreasing, because the object will slower down. And once the object is fully immersed, the upthrust will become constant. This time T2 is the time when the object is fully immersed. Now there are two important things. This is during immersion, and when it is fully immersed, after that no change in upthrust will further occur. So once the object is fully immersed, then no change in upthrust will occur. We should say that from T1 to T2, the object is being immersed in the liquid, and the common experience is that the speed of the object will be decreasing. The upthrust during immersion, the upthrust during immersion, the upthrust during immersion in the liquid will increase as during immersion from T1 to T2, the immersed volume the immersed volume would have been increasing. Once the object is fully immersed, after T2, when the object is fully immersed, then the upthrust will remain constant as the immersed volume will have no further change. That's why after T2, the upthrust becomes constant. Okay, students, this was all about upthrust. In the next slide, we'll cover the topic forces in frictional forces and viscous drag.